Hey everyone, welcome to Module 4. We are going to be going over your project draft that is due in this particular module. So you'll want to go to Module 4, you can click on the link here, and here are the guidelines and rubric. As always, you will want to review this information very carefully. This is telling you how to complete the assignment, and then of course you have your rubric to act as your checklist. And you have a template for this. I'm going to go ahead and open it. And this is basically just the template that you can use. And it's a copy and paste kind of thing where you can, remove the information here and post in your answers. So let's go ahead and look at what is being asked for here. So the first thing is that you're still using your science issue that you chose and your 3 sources that you did in the in Module 2 project. So what we are doing in this particular project is we are first going to describe the issue and how it impacts equity in your community. So basically, how would you describe this issue to someone who is not familiar with the particular science behind it? So you would probably want to pretend like this person doesn't know anything about your issue. And then talking about how it can impact certain populations disproportionately. So for instance, if you choose climate change and you chose like sea level rise, people that are going to be disproportionately impacted by that are people who live in island communities because they don't have anywhere to go. If the sea level rises, the island becomes inundated with water and they can no longer live there. Versus somebody who's living in a landlocked area might not be as impacted by sea level rise because they're far from the coast, they're not living on an island. Another good example would be pollution. Most pollution, water and air pollution, tends to occur more disproportionately in poor communities, low income, where there's a definite discrepancy between rich and poor. So, affluent communities tend to have better natural resources and cleaner water and cleaner air versus communities of color or communities that do not have as much discretionary income. So after you complete this, you are going to look at the data of your issue, the relevant data. And essentially what you're doing is you're taking the data and that you can find about your issue and talk about like what is the data supporting. So for instance, climate change, there's data between temperature and CO2 levels, right? And so that would be a main point supported by the research that as, CO2 levels increase, the temperature increases. And you want to, in this particular case, include any relevant data that you've found. So any kind of charts or figures, and then you want to discuss them, right? So this particular example I have here is what they believe is going to happen with microplastic pollution in the tropical Pacific. So like, the trend or, the relevant part of this data is showing you that more than likely microplastic pollution is going to continue to increase as the years go by, based on the fact that we've already collected a lot of microplastic pollution data. And I would want to find that, I'd probably want to find like a chart that might list how much microplastic pollution was identified by drones or by people in this particular area, and what the basis is for saying that more than likely it's going to increase. So that's the relevant part of the data. Now, it's going to be different depending on your topic, right? Then you want to look at validity. Oh no, my picture got cut off. So validity is, is this data that you have found good, or on the opposite hand, maybe it's not good. So I'm sorry that this picture got cut off, but this is essentially showing you an ad from the 1950s that made the claim that more doctors smoke Camels than any other cigarette. So this is kind of a piece of data because, people would see this ad and they would say, well, doctors are smoking cigarettes, so therefore it must be healthy, right? Like we're having some biases here. And, in the 1950s, this was considered the gold standard, right? But we're in the 2020s, and we know that this is not current and this is not accurate. Whereas, this chart is a little bit more current and accurate because now it's showing the link between smoking and smoking cigarettes and cancer. Now, this particular piece is from 2011. So it's not very current. It is still accurate, but it's more than, it's a couple of decades old almost. So we want more current and up-to-date information. So it's okay for you to find data that is a little outdated, but you just want to discuss what its currency means and is it still accurate. So looking at those resources from the module about validity is going to be really helpful as well. Now, if you need to find data sets, that Sage Data link that I gave you in the class announcements is really helpful to look at data for different topics, and finding, things online is okay. You just want to make sure that you're kind of keeping track of all of your references and resources. So the next part is trends. So you're going to look at the trends in the data. Remember that's kind of looking at graphs and data sets. So is there a positive trend where like it's showing that the graph, is going up? Is there a negative trend where it's going down? So for instance, like, where is it? So this graph would be a positive trend because it's showing an increase between these two variables, right? So you would want to look for information like this because that is a much easier trend to identify than necessarily like a bar graph like this. So the line graphs are kind of like the gold standard to be able to see trends in the data. That's not to say that you couldn't find different types of graphs to see the trends. But if you're looking at positive, negative, and stable, or a combination, the line ones are the best ways to see that. Then you're going to be looking at relationships. So you're going to look at the relationship between the variables, right? So you've got your independent variable is always on the x-axis, your dependent variable is always on the y-axis, and you're looking at, what is the relationship between these two variables. So you're essentially looking and trying to make connections, and how can it help describe the relationships? So I've given you two examples here. So in this particular graph, this is showing you the incident of measles cases in the US at different years. And so you can see right here, right, like there was a kind of rise and fall in measles cases. They were very high before vaccines were implemented in 1963. So there was, you can see when they were able to give vaccines, those numbers dropped pretty drastically. And then as more, vaccines came up, those numbers dropped even lower. Now you can, you would want to describe why you would see drops in this first part without the vaccines. And most of that was due to seasonal, right? So like, how we have seasonal flu, measles was seasonal as well. Cases would tend to rise in the fall and winter, and then they would decrease in the spring and summer. This graph right here is showing you the correlation or the relationship between temperature, which is in kind of like this reddish orange, and carbon dioxide levels. And so the relationship you see here is that as carbon dioxide levels rise, so do the temperature levels. And as the carbon dioxide levels go down, so do the temperature levels. So that's all you're doing. You're just discussing the relationship. And again, it would be really helpful if you had some type of graph, even if you had to create it yourself with data that you found. That will make your presentation all the more better and relevant, and being able to clearly see, how you're interpreting the data and the trends and the relationships. And that's it for this particular project draft. Let me know if you have any questions, if you need resources, help interpreting some of the data that you have. I'm more than happy to kind of troubleshoot it with you.